Hello guys, today we're going to start 2.6 combinations of functions and the composition functions. So first we're going to focus on the combination functions. Alright, so we're going to start example 1, finding the domain of each function. So let's look at part A. We have f of x equal to x squared minus 7x. When you're talking about domain, we're just going to talk the restriction for your x. In this case, x squared minus 7x, if you realize that is just the special case of polynomial quadratic function. So you should realize there's no restriction for this. So we can use the number line. We're going to say all the real number works for this case. So I can write the domain just going to be all the numbers that will be negative infinity to positive infinity. Right, for part A. And then we'll look for part B, g of x equal to 3x plus 2 over x squared minus 2x minus 3. So in this case, x squared minus 2x minus 3, that is our denominator. We know that our denominator cannot have 0. So then we solve this. We factor it, we're going to have x minus 3 and then x plus 1 cannot be 0. So we're going to end up with x minus 3 cannot be 0 or x plus 1 cannot be 0, which gives us x cannot be 3 or x cannot be negative 1. So for this kind of case, when you have a or in this case, alright, so let's go ahead just write this on the number line really quick. So we're going to have negative 1 right here. We also have the positive 3. Right, positive 3 right here. So we actually have to exclude those 2 points. So we can't have those 2 points. And then everything else works. Only those 2 points doesn't work. Okay, so we're going to write this for the number line. We're going to start with left to the right. So that will be the negative infinity to negative 1. Okay, remember this is exclude this point, so that's why we use the parenthesis. And then we have to use this symbol right here, that is or, look like a U. Then from here, that will be from negative 1, so we'll stop by 3. Again, it's exclude, we need to use a parenthesis. We're going to have or. We have from 3 to all the way to the right side, that will be the positive infinity. Okay, that is how you write this type of question. So for this, let me just highlight this part. For this or, it's just a symbol. I'm not sure if I mentioned this before. If you can think of this as 2 circles, alright, so I'm just going to write it down. So we're going to say this is set A and set B. I'm just going to explain the concept of what is this symbol means. Okay, so if we have a set A is equal to, let's just make an example. Set A is 1, 2, 3, 4, 5, and then we have a set B equal to 4, 5, 6, 7. Okay, so when we say the or, we're going to read it like this. That just means everything in there. Okay, so that just means everything. Now I'll start with 1 to all the way to 6. Alright, we're going to write it down. All the way to 7 actually. Another symbol. Alright, this we're going to read it as and. Okay, so if we have an and, that means we're going to have a set A and set B the same thing. Okay. When we talk about and, it's just they are both have to satisfy this condition. Okay, so if we have set A and set B the same thing on the left side, that just means if you look right here, we have 1, 2, 3, 4, 5, and then 4, 5, 6, 7. We have to satisfy both of them. The only part to satisfy both of them is 4 and 5. You don't have to know there's a whole set thing yet. Okay, you might learn this later, but the main part you need to know is, okay, you need to understand what symbol means. Okay, that is the reason why we use this here, because everything, all the yellow part, that actually works. So that's why we start the left, okay, and then you remember this almost like you're cutting it to 3 intervals, right? You can imagine this, you're using this red circle right here that's cutting to 3 intervals. That's why you have negative infinity to negative 1, and from here you're going to have negative 1 and 3, and then from 3 you have a positive infinity. When you're writing this, we mentioned that this in the past, you always want to make sure to start from the left. Writing the number line definitely going to help you to write this notation form. Okay, let's look part C. Part C, we have h of x equal to square root of 3x plus 12. So you have to recall this from the old knowledge. If you have a square root, everything inside here, that means 3x plus 12 must be greater or equal than 0. Okay? This is the case anytime you're dealing with square roots. So when we set this greater or equal than 0, so we can solve this. That will be x greater or equal to negative 4. So again, when you're dealing with this, we're going to write it on the number line. So I'm going to start with, I'm just going to say this is a negative 4. We're going to use a solid line because it's greater or equal. Okay? And then since it's greater or equal, so we're going to go ahead and use this. We're going to go this side, everything on this side that work. Okay? So that means if I write it in the notation form, I'm going to start from the left to the right. Since it's a greater or equal, we have to include this negative 4 that use a big bracket, and then to all the way to the right side, that will be the positive infinity. That is our domain. Part D, we have a 3x plus 2 over square root of 14 minus 2x. Okay, so here a little bit tricky. We have to think about two things. So first we know the denominator cannot be 0. Also, we still have to deal with this portion, alright? Square roots, like what we said earlier, that means this whole thing has to be greater or equal than 0. From the square roots, I'm going to separate two parts. Means, alright, this implies 14 minus 2x is greater or equal than 0. So that is one piece. But another fact is, since this is a denominator, okay, we said the denominator cannot be 0. That means we have to make sure to satisfy both. That means we only can have 14 minus 2x greater than 0. Okay? Make sure you understand this. From square root, we're going to have this whole thing greater or equal than 0. But since it's a denominator, it cannot be 0. That's the reason why we're going to have 14 minus 2x greater than 0. Alright, so from these two pieces together, so we finally have this condition. So once you understand this, the rest of the stuff is easy. We're just going to solve it. So we're going to solve this. You're going to have negative 2x greater than, moving to another side, that will be negative 14. And then we're going to divide by negative 2. Anytime you divide by a negative number, you're going to change the sign. So we're going to have an x less than 7. Alright, so we're going to have, I wrote it down right here. Anytime I divide a negative number for the inequality, we'll change the sign. So that's the reason why where this come from. Okay, that is where this less than 7 come from. So again, we're dealing with this type of question. We're going to write this down a numbered line. We realize it's less than 7. Alright, that will be an open circle. So here is the 7, and then we say everything this side, that is our solution because it's less than. Again, when we're writing the domain, so we're going to write down from the left to the right. So we're going to start with negative infinity, and then we'll stop at 7. Since it's less than 7, so it's an open circle, we're going to have parentheses. That is your final answer. Let's go ahead and look at the algebra of a function, sum, difference, product, and the quotient of a functions. Okay, so for this, the main thing is you want to remember is this 4 parts. Okay, so this is the 4 of them. When we have a sum, okay, if you pause this video, then take a look. Then we're doing some examples that will make a lot of sense for you. Okay, the part is I want you to also pay attention is, so when you're dealing with domain, the new function you find, and right here, okay, we mentioned this early, so it has to be satisfied both the domain for f and the domain for g. Okay, let's look at example and then hopefully make sense to you. Okay, example 2, we have f of x equal to 2x minus 1 and g of x equal to x squared plus x minus 2. Find each of the following functions. So for part A, we're looking for the sum. Okay, so if you go back and look at the definition given to you, that just means it's f of x plus g of x. So that means I'm just do a substitution. We're gonna have f of x substitution right here. Okay, that's your f of x right there. Substitution, that will be 2x minus 1 and plus g of x. G of x is right there. That is x squared plus x minus 2. There's a whole thing it'll give you. We're just going to collect like terms and then simplify it. That'll be x squared. Then we're going to have 2x plus 1x. That will be 3x. And then here, negative 1, negative 2. That will be negative 3. Okay? So that is your first answer. Once you find this, you also need to find the domain. In this case, hopefully you realize this is just a polynomial. Polynomial, earlier we have mentioned, the domain just going to be all the real numbers. Part B, we're going to have f minus g of x. So again, that just is f of x minus g of x. Okay, so this is very similar to the question you have done early. All you're doing is a substitution. Okay, subtract, you must put a parenthesis there, otherwise you're going to make a mistake. So that will be 2x minus 1 minus x squared minus x and plus 2. I just take this out of parenthesis, and then I'm going to simplify it. That will be negative x squared, 2x minus x, and then just going to have 1x left, negative 1 and plus 2, that is just a plus 1. That is a part B. So that is your solution right here. Okay, let's put down the solution. So for here again, this, if you look again, this is a polynomial function. All the real number works for x. This is going to be your domain is negative infinity to positive infinity. Part C, fg of x. Alright, this is just the same thing as f of x multiply g of x. Again, this is f of x, this is g of x. And between is a multiplication. Okay, so that will be 2x to the third power. Okay, then we're going to have a plus 2x squared, and then we're going to have negative 4x. And then here we're going to have this part that will be subtract x squared, and then subtract, then here's a subtract x, and then here we're going to have plus 2. Then we're going to simplify this. You're going to have, okay, so we'll look at the third power. We're going to collect like terms. Again, this is just a polynomial. Okay, so we're just going to have a domain. It's just going to be negative infinity to positive infinity. Okay, it's very straightforward. So here is a part D. So if you have f of a g of x, we're just going to have f of x over g of x. Okay, so again, it's a substitution. You're going to have a 2x minus 1 over x squared plus x minus 2. So once you have this, you know, we can't really simplify this anymore, so nothing we can cancel either. That's just your solution. So then we have to realize, okay, what is our domain? So now we're looking for a domain. It's very similar to the question we have done in example 1. So we just set this denominator cannot be 0, then we'll solve it. You're going to have x cannot be negative 2 or x cannot be 1. Okay, so that means when I write this domain, all right, let's go ahead and write it on the number line. So we're going to have negative 2 right here. We're going to have a positive 1 right here. Remember, we said before, let's use a green color. All right, everything else will work. So only those 2 points doesn't work. Only those 2 we have to exclude it. So when we write this, we're still going to write from the left to the right. Just thinking about the coordinates is 3 interval, and then you write it down. Now go to -2, okay? Parenthesis, because we have to exclude it. We can't have -2. Then we write down or use this symbol, and you can find this symbol on your Math Excel as well, okay? From -2 to 1, and then or from 1 to the positive infinity. It's very similar to the question we have for example 1. Alright, so that is our part D. And then let's work on one homework question. I find a lot of students struggle with this question on your homework. So let's work on this. So similar stuff, we need to find each of them. Then we're going to try to find out what is the domain for each piece. Okay, so let's work on each of them. It's given to us f of x equal to square root of x minus 1, g of x equal to square root of x minus 6. So we have x plus g of x, alright, just equal to f of x plus g of x. The question itself is really straightforward. I find the student don't have struggle with that part. I think the part is about the domain, okay? All I did right here is doing the same thing, alright? So I'm just doing the substitution. Okay, really straightforward. Then here we have to deal with the domain. We're going to look at each piece, okay? For this part, we find that x is minus 1 has to be greater than or equal than 0, right? Because it's a square root form. So then I solve it, I'm going to have x greater or equal than 1. So we're going to write x greater or equal than 1 in this number line. Okay, so let's see. So I have a 0, let's write 0, and then make sure we write 1. Since it's greater or equal, so let's make sure, let's use this. So that will be in this form, right? Greater or equal, go to the right side. And then we're also going to look at the second piece. We're going to have second piece, we can do the same thing. We realize it's x greater or equal than 6. Okay, so I'm just going to use a blue color here. So if I'm just going to say this is 6 right here, then I'm going to write down greater or equal than 6 as well. So it's a solid circle. If you want to go back, okay, right here. The definition tells you the domain of your new function is the domain of your f and domain of g, alright? So it means these two pieces have to satisfy both conditions, just like here we earlier mentioned what the symbol, this symbol means, alright? That symbol is the and. Okay, satisfy both conditions. So in this case, all you have to realize is the overlapping part is your final domain. Okay, in this case, the overlapping part is actually greater or equal than 6. So I write it in the notation form. That will be bracket 6 and positive infinity. Okay, so the same thing is f minus g of x is very similar. Okay, so this is the same thing. We also have fg of x equal to f of x multiply g of x. Okay, so the substitution part, I think everybody can do this. Then we just multiply them. You can do full method. You can end up with something like this. Okay, so that is your answer for this portion. And then for the second part about domain, okay, so when we're dealing with the domain, so it's very similar what you have done so far. It's exactly the same thing. You have to find the overlapping part again, which is you already know what that is. Alright, 6, and then put the positive infinity again. Alright, the last part is f over g of x equal to f of x over g of x. So the substitution part, you are all good with this. Alright, so then from here, you have to simplify it. Before you simplify it, two things you have to realize, okay? So you realize there's so many conditions right here. This at the top tells me x minus 1 must be greater than equal than 0. And then this on the denominator, you have to make sure you know this is just going to be greater than 0, right? Because the square root of x minus 6 is a denominator. This cannot be this whole thing cannot be 0. Okay, that's the reason why we have a greater than 0. Alright, so that is some piece you need to know. So let's just finish this really quick. So we're going to simplify it. So when you simplify this, okay, because we can't have a denominator have a square root, so you're going to multiply the square root of x minus 6 over square root of x minus 6. And then from here, you just simplified it. So we already done this similar stuff early, so we're going to have something like this, then over x minus 6. Okay, so that is your solution. And then your domain from this information right here, x minus 1 is greater than or equal to 0. Okay, x minus 6 is greater than 0. On your number line, you're going to have x greater than 1, so that is solid circle. Okay, so let's use this color. So solid circle here, and then you also have another piece. This is going to be, okay, this is going to be x greater than 6, right? This has to be an open circle, right? Open circle right here, greater or equal. Since we have to look at the overlapping part, the only overlapping part works, that will be the 6 to the positive infinity. The reason why you're going to have a parenthesis right here, because we have to exclude the 6, okay, because there's no greater equal sign, there's only greater sign there. That is the reason why you're going to have this. Okay, this is so important. I have so many students get it wrong. This is the parenthesis right here. Okay, the reason why, because of this piece right here. Okay, that is the reason why. Hopefully this will help you with your homework. Thank you for watching the video. I will see you guys next time.